This is a video for Homework 2, number 12. This is 8.1.25-T. Okay, so here we have that the shape of a distribution of the time required to get an oil change at a 20-minute oil change facility is unknown. However, records indicate that the mean time is 21.2 minutes and the standard deviation is 4.8 minutes. Okay, so let's take a look at letter A. It says to compute probabilities regarding the sample mean using the normal model, what sample size would be required? So whenever we want to use the normal model, this has to do with our central limit theorem, the larger sample size the better. We are going to always make sure that our sample size is greater than or equal to 30. So if we want to use the normal model, this is the one we're going to talk about right here. Sample size needs to be greater than or equal to 30. Now let's take a look at letter B. What is the probability that a random sample of n equals 35 oil changes results in a sample mean time less than 20 minutes? Now, what we're dealing with here is a sampling distribution. So we're going to use our normal calculator in StatCrunch to help us out with this. So you're going to go to Question Help and go to StatCrunch. And just to kind of show you the difference between a sample distribution and a sampling distribution, I just want to show you the view of the example here. Get past letter A. So one thing I want you to remember is that whenever you have a sampling distribution, take a look at this little kind of tidbit here. What you have here is that your mean x bar, which is a sample mean, will have the same as the mean of the population. So we're just going to keep our means the same. So I'm going to take that same mean, which what they told me was 21.2 minutes, and I'm going to use that in my calculator. However, the standard deviation changes. So the standard deviation we're going to use is going to be whatever we were given the standard deviation, but divided by the square root of n. So that's what happens in a sampling distribution. We always want to divide that standard deviation by the square root of n. Okay, so I just wanted to show you that so you kind of get an idea of that. So going back to StatCrunch, I'm going to go to Stat, Calculators, and we're going to go down to our normal distribution. And I'm going to put in my mean. Again, that was what, 21.2 minutes? So I'm going to put 21.2 in here. And we have to find the standard deviation that we're going to use. I'm going to minimize this for a moment and just open up my Google Calculator. And the standard deviation that they gave us was 4.8 minutes, but we're dealing with a random sample of 35. So we're going to do 4.8 minutes, and then we're going to divide by the square root of 35. So 4.8 divided by the square root of 35. And what I would just do is copy and paste this into your normal calculator. So I'm just going to copy that, go back into StatCrunch, and paste that in. Okay, and press compute. You can see how that's going to affect your distribution. Now I'm just going to minimize this for a moment again. They want the probability that the sample mean time is less than 20 minutes. So we're going to go into our calculator here and see where it has the probability. We want the probability that x is less than or equal to, and we could also change this to greater than if we needed to, but we're doing less than or equal to 20. And press enter. So you can see here we're getting 0.069566749, which if you look at the answer that they got, they're rounding to 4 decimal places, so they're using 0.0696. And that would be correct because right next to my 5 there is a 6, so this would round up. Okay, let's take a look at letter C. Suppose the manager agrees to pay each employee a $50 bonus if they meet a certain goal. On a typical Saturday, the oil change facility will perform 35 oil changes between 10 a.m. and 12 p.m. Treating this as a random sample, there would be a 10% chance of the mean oil change time being at or below what value. So we're looking at what x value, what time, okay, is going to give us a 10% chance of getting below that time, because the manager doesn't want to have to pay out everybody this bonus. So they want there to only be a 10% chance that this could actually happen, that a person would actually get this. So what we're going to do is go back to our normal distribution. We're not going to touch our mean and standard deviation because we're still dealing with a sample size of 35. We're going to get rid of this 20 that we entered, and instead we're going to put in our 10% here. So I want at or below, so less than or equal to 0.10, and press compute. So the value that would make this have a 10% probability would be the 20.160216. And let's see what they got here. They're rounding, I believe, they're rounding to 1 decimal place. So 20.2, because next to this 1 there is a 6. So StatCrunch makes that so much easier for us to work with. If you have any trouble with that, let me know.